Hi grade 12s and welcome. In this video we're going to solve the Mathematics Paper 2 May-June 2024, which is the supplementary examination paper. So let us get straight into question 1. Right, so in question 1 what we have is linear regression and correlation. The number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. The data is also represented in the scatter plot. Right, so they have already plotted this for us, and we can see a nice graph here with all these scatters, with all the dots, with the x-axis, which is the number of pages, and the y-axis, which is the weight in grams. Number of pages is x, weight in grams is y, and these are all the coordinates that are plotted here. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so there are 10 values. You should have 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so everything is plotted. Let's read the first question. Determine the equation of the least squares regression line. How are we going to find the equation of the least squares regression line? We are going to write down from the formula sheet. We have a formula which is y equals a plus bx. That's the equation of the least squares regression line. It's an estimated line, so I'm just going to put an estimate. Now how do we work it out? We just use a calculator and get the values of a and b. A represents the y-intercept, b represents the gradient of that line. Now let's check. So how do we enter all these values? Let's enter all these values. Press mode, stat, and a plus bx, option number 2. Now you see frequency, put the frequency off. Press shift mode, scroll down, go to stat, option number 4, put your frequency off, option number 2. Now let's enter all the x values. Entering all the x values is 85, 150, 100, 120, 90, 140, 135, 105, 115, and 160. Now enter all the y values. Entering the y values 165, press equals, then 325, 200, 250, 180, 285, 250, 170, 230, and 340. Right, so what I'm going to do is I'm just going to double check all the values if I have entered it correctly with my coordinates. 85 and 165, 150 and 325, 100 and 200, 120 and 250, 90 and 180, 140, 285, 135, 250, 105, 170, 115, 230, and 160, 340. So everything is good. Let's put our calculator on. Press shift 1, go to stats, regression mode, option number 5. Select option number 1 for a. A is equal to negative 43,72. So the value of a is negative 43,72. Let's write that down. And the value of b is, let's check, it's upward sloping lines, so you can see plus, put a plus there. And the value of b is, put your calculator on, shift 1, go to regression, option number 5, press option number 2, and you get the value of b, which is 2,36 x. Right, so I use 2 decimal places, and that's your answer. Let's move on to the next one. Draw the least squares regression line on the scatter plot in the answer book. So I'm going to do it on this graph here because I don't have the answer book. So how are we going to draw this graph? To draw this graph, choose some nice points that lie on this graph here. Example, let's go to 80. If I put a value of 80 in the equation, I just need 2 points to draw a straight line. Okay, so I'm going to choose some nice points here. I'll probably choose the point 180, and I'll choose another point which is like 40. So that's what I will do. Should we clear this mode? Maybe let's check. We might need that mode. So did they ask for correlation coefficient? No, they didn't ask for correlation coefficient, so I think I can clear this mode. Right, so let's go to mode 1. Negative 43,72, negative 43.72 plus 2.36 into 180. I'm just putting the last point there and see what answer I will get. I will get an answer which is 381,08. I want to see if I got 381,08 or approximately 380 for at 180. So I'm doing basically question number 1.2. So for 1.2 I'm getting a coordinate when I'm putting 180 inside. I'm getting an answer which is 381.08, right? And I want to try a lower value so that I can join the two lines. Let me try a point at maybe I can't try a point. Can I try a point at 0? No, then I will get a negative answer. That's a y-intercept. Let me try a point at 100, because remember you just need 2 points to sketch the line. Let me try a point at 100. 100 is going to give me 192.28. 192,28. Right, so I've got these values, and now let's plot it here. I think these are going in tens. 360, 370, 380. So I've got 380 here for 180. I've got 380. 380 should be the second line down, just right there. Okay, 380, right? And the other line is 100 and 192. 100 and approximately 190. 190 will just be under the 200 mark. I'm getting somewhere around there. Okay, that's 190. So that's 50, 60, 70, 80, 90, 100. Let's see, what is this point? This point is 200 here. Point is 150, 100, and that's 50. 60, 70, 80, 90, 100. So I think I'm doing the right thing. 190 is here. Come to 100. Right. You got your two dots. Remember, you just need two coordinates to sketch the straight line. And which least squares regression line you need to draw? You need to draw this least squares regression line. Okay. So that's a line that defines. Now the purpose of the least squares regression line is that you'll find that all the points are clustered around, all these scatters are clustered around this line here. So now when you're drawing this line, make sure to draw it on the entire scale. Right, so I'm getting a point something like this. Right, so that's the equation of the least squares regression line. As you can see here, the deviations are like very tiny. Just 1 point is like far away from this line, but anyways, that's my equation of the least squares regression line. Alright, so I hope you guys understood that. Moving on to the next question. Predict the weight. Right, so this is a nice question. Predict the weight of an A4 book that has 110 pages. Right, so predict the weight of an A4 book that has 110 pages. Now remember, 110 page book, right? We're going to predict the weight. Now what is 110? Is it X value or Y value? As you can see, number of pages is X, so it's the X value. We're going to put X inside the prediction line. So we're going to say Y is equal to negative 43,72 plus 2,36 times 110. Right? That's 110. Okay, so I'm getting an answer of 215,88. So approximately 216, what is that in grams? Yeah, approximately 216 grams. Right, so I hope you guys are understanding. Let's look at the next question. The next question says, calculate the percentage weight increase between a book with 110 pages and a book with 130 pages. So percentage weight increase, remember the percentage weight increase is that's a weight. So 110 is giving me 216. Let's use the actual values. 215,88 and 130, y is equal to negative 43,72 plus 2,36 into 130. That's giving me, if I substitute 130, what is that giving me? Right, so delete, put 130. That's giving me 263,08. So you're going to take final minus initial over initial. Percentage increase is equal to final 263,08 minus 215,88 divided by what was the initial. The initial was 215,88 and then multiplied by 100. Right, so we're going to take those differences and multiply by, right, so 263.08 minus 215.88 divided by 215.88, right, and multiplied by 100. So I'm getting 21,86%. So 21,86%. Let's check if this answer is correct. So we're going to take 215.88 into 1.2186. That's basically 100 plus 100% plus 21.86%, and that answer is giving me 263,07 approximately. Alright, so this answer should be fine. So the percentage increase is 21,86. In other words, 21,86% is a percentage increase from a 110 page book to a 130 page book. Right, so I hope you guys understood that. Next question. 50 athletes needs to access suitable training facilities. The table below shows the distances in kilometers that they need to travel to obtain access to suitable training facilities. Complete the cumulative frequency column provided in the table in the answer book. Right, so I don't have an answer book, so I'll just do it right here. Right, so I'm going to draw the cumulative frequency table. Just put an extra column here. Right, and I'm going to call it cumulative, right, cumulative frequency. Right, so the 3 from here will go there, then 3 plus 7 is 10, 10 plus 20 is 30, 30 plus 12 is 42, 42 plus 5 is 47, 47 plus 3 is 50. So this is done. We completed the cumulative frequency table. Next, on the grid provided in the answer book, draw a cumulative frequency graph, Ogive, to represent the above data. Now I don't have the answer sheet, so I'm going to draw the Ogive curve right here. Now how you draw the Ogive curve? We need the upper class boundary and the cumulative frequency. So let me just copy this for you, right, to check what points we need. So the points that we need are, let's make this small. Right, so these are the points that we need. We need the upper class boundary, right, and the cumulative frequency to draw the ogive. Right, we need 15. These are the points, x values, y values. 20, 42, 25, 47, 30, and 50. And remember, there's one more point, which is the minimum, 0, 0. So don't forget about the point 0 and 0. That's another point there. Right, so let me draw the graph. So I'm going to go intervals of 5 to 30, right? So let me just do some estimation here, right? So let's draw the graph. Let me draw the y-axis, which is the right, and remember on the y we're going towards 50. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So a little bit more space here. Right, so obviously you have the grid, so you can draw it much better. Okay, so we got 5, 10, 15. That's the interval that I'm going to use. That should be good. Right, so let's use 5, 10, 15, 20, 25, 30, 35, 45, and 50. How we know we have to end off at 50? Because that's the y values, right? 50. So this is what you're going to put on the y-axis. You're going to put cumulative frequency. Cumulative frequency, alright? So let's write this down. This is the cumulative frequency. Right, that's a cumulative frequency. On the x-axis, you're going to put the distances, the class intervals, right? So I'm going to try to use the same gaps here. 5, 10, 15, 20, 25, and 30. Some of the gaps got smaller. And right, so we have 5, 10, 15, 20, 25, and 30, which is the x values. These are the cumulative frequencies, and this is the ogive, right? Now, the first point is 0, 0. So we put 0, 0 here. The next point is 5 and 10, 5 and 3, right here. Next point is 10 and 10, should be on the line. Next point is 15 and 30. X value is 15 and 30, right? So there's a big gap here, big jump. Just trying to get it in line with the 15, right? Next one is 25 and 42. 25, no, next point is 25. What we had? We had 15 and 30, 20 and 42. 42, all right? Next point is 25. Let's try to get it in line. Right, so I'm just going to try to get it in line with the 20 and 42. 42 is somewhere around here. 40, 42. Right, next point is 25 and 47. 25 and 47 obviously is higher up, and then the next point is 30 and 50. Right, so that's my last dot. I just want to check if these things are lined up as well. Okay, just a bit off. Let's take this out because it was 15 and 30, right? Right, so and the rest is all fine. Right, and now we're going to draw this ogive curve. Now remember, we're drawing the ogive curve, just draw it freehand. Right, it's a S curve. There's a sharp incline there. I just put off here. Right, and that's my ogive curve, right? Because last point we had was 30 and 50, right? So I hope you guys are understanding. Moving on, calculate the IQR of the above data. Now to calculate the IQR, we have to take Q3 position, right? Because IQR is Q3 minus 1. Now Q3 position, I'm trying to get the position. Q3 position is 3/4, right, of n. You can use n or n plus 1. So it's going to be 3/4 of n. What is n? 50, the total number of data. So 3/4 of 50. I think yeah, 3/4 of 50. Supposed to be n plus 1, right, to get the answer. Or you can use n because it's just an estimation. So 3/4 of 50. 3/4 of 50. That is just it's a position. So we need to go 37.5 position on our y-axis. 37.5. Right, and Q1 position is equal to quarter into 50. A quarter into n, right? Let me just write n here. And the median will be half into n, right? And over here I think you're going to get 12.5. Right. Now remember, we're going to find Q3 here by reading off from the ogive. Therefore Q3 is equal to, let's read off the ogive. We're going to 37.5 position. 37.5 will be in between 35 and 40. If it's in between 35 and 40, let's take a line and show you where it is, right? So you're going to go here, see it touches that ogive, and read the value on the x-axis. Let me see if this line is straight. Yep. Let's read off the value on the x-axis. Now reading of the value on the x-axis, it looks like it's in between 15 and 20. So which value can we take here? 17, 15, 16, 17. Yeah, let's take 17. 17 or 18. Okay, you allowed one deviation, so I'll just take 17. Alright. And the next one is Q1 is equal to 12.5 position. 12.5 position is going to be in between here 10 and 2, right? So now I'm going to go down from here. So I'll take 11, alright? I just one after 10. So I will take Q1 as 11. So I hope you understand how to find it, right? You have to read off the values on the x-axis. So this is Q1 and that's Q3. Now let's solve. So IQR is now equal to the difference in these x values, which is 17 minus 11, which is 6. So I hope you guys are understanding. So I've got 6 as my IQR. Right, next question. The families of 4 of the athletes above who stay between 15 and 20 kilometers. Right, so we're talking about this one here now. Let's put this graph here. Who stay between 15 and 20. So they stay here, right? The families of 4 of the athletes above who stay between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. So 4 of them from here is no more 4 now, and it's no more 12 now, it's going to be 8, moved to 10 kilometers closer to the facility. So that's the distance away from the facility. So they moved here, no more 7, is going to be 11, 7 plus 4. So you minus 4 here, let's not strike it off. So we minus 4 here to get 8, right? And we're going to add 4 here to get 11, right? So they moved here. In which intervals will the number of athletes increase? Between 5 and 10. That's the interval of increase. That's where it will increase, right? Pretty simple. Next one. Next question, what we have here is calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all working. So we want to calculate the estimated mean, all right, of this new data here. So let me just copy and paste it here now for you. Now to calculate the estimated mean, remember we also need the midpoints. All we need to work with is midpoints and frequency. So this is your frequencies, right? And now what we need is a midpoint. We don't need cumulative frequency now, right? So let me take that out. We just need midpoints and frequencies. So we're going to be working with the same table, but all we need is midpoint and frequency. So let's work with this table here, and we're going to put midpoints. So let's just put x midpoints, right? Midpoint of 0 and 5. 0 plus 5 divided by 2 is 2.5. 5 plus 10 divided by 2 is 15 divided by 2 is 7.5. 10 and 15, that's 12.5. And just be careful where you're putting it. 7.5 should be there. Then it's 12.5, which is correlating with the 20 here. Right, so remember this is the frequencies and that's the midpoints. And then we got 15 and 20 divided by 2 is 17.5. You can find like a pattern here. And then we got 22.5, right? And then we got between 25 and 30, which is 27.5, right? And now we're going to find the estimated mean. I'm just going to use a calculator and calculate it. How do we do this? We just enter these values and these values into the calculator. Now what are the values you're entering? You're entering the 3, the 11, the 20, the 8, the 5 and the 3 with these values, right? Right, so let's enter all the x values, then we'll enter all the frequencies. So go to mode, put your calculator on, right? Go to stats, mode, and press stats, one variable data. Now remember we switched off the frequency. Now we're going to put our frequency on. So press shift mode, scroll down to stat, option number 4, and put your frequency on 1. Now you see x and f. X is the midpoint, so it's 2.5, 7.5, 12.5. Wait. What happened here? 2.5, 7.5. Midpoint is 12.5, 17.5. Keep on making mistakes because of the 0.5s. Go up. 17.5, then there's 22.5. Right, so I just need to go back up to 17.5. Enter 17.5. Right, so I'm going to do it again. Make sure everything is correct. 7.5 should start with 2.5. then 7.5, then we have 12.5, then 17.5, then we got 22.5, then 27.5. Right, so we have everything. Let's do it again. 2.5, I need to delete that data. Alright, so 2.5, 7.5, 12.5, 17.5, 22.5, 27.5. All good. We got 6 values, 1, 2, 3, 4, 5, 6. Now let's enter all the frequencies. The frequencies are 3, 11, not 7, 11, right? Then 20, then 8, then 5, then 3. Right. So let's see again. We got 3, 11, 20, 8, the one that's colored blue, and 5, and then 3. Now put your calculator on, press shift 1, go to var option number 4 and select option number 2, right, and that will give you the estimated mean, which is 13.5. Right, so I hope you guys understood that. Now, is there another way to do it? Yes, there is another way to do it. You can take 3 times 2.5, 11 times 7.5, or estimated mean is equal to sum of all x times f divided by the total number. So let's do it like this as well. What is sum of x times f? You can work it out. Put your calculator on, go to mode 1. So what we're doing, 2.5 times 3 plus 11 times 7.5 plus 20 times 12.5 plus 8 times 17.5 plus 5 times 22.5 plus 3 times 27.5. Right, so we got 675, and we're going to divide it by the total number data, which is 50, and let's see what answer we get. We get 675 divided by 50, and I've got 13.5. So both ways is correct. Remember, that's a formula that's given in the formula sheet. Let's continue on to the next question. Right, so now we are on analytical geometry. In the diagram A, B, C are vertices of triangle ABC. Make sure you read all the information, because sometimes there's important information that you miss out if you don't read. AB is produced to S, line AB is produced to S, okay? D and F are the x and y intercepts of AC respectively. Remember, the equation of AC is given. The equation of BA is not given, it's given as KX. Anyways, F is the midpoint of AC. Very important information. F is the midpoint of AC. So let's go and put a midpoint here. Alright. F is the midpoint of AC, and the angle of inclination of AC is alpha, as we see here. Can we find the angle of inclination? Yes, we can. We can say tan theta equals to the gradient of this line. Tan alpha is equal to the gradient of this line, which is 2. Right, so we know how to find alpha. Right, so far so good. The equation of AB is y equals kx plus 3. The equation of AB is y equals kx plus 3, as is shown there. And the equation of AC is 2x minus 2. Equation of AC is 2x minus 2. Right, so far so good. All the information, what you see here, is presented here. Right, so now the next question, they didn't tell us whether if B is the x-intercept here. Did you read this? Maybe we can assume later on. I can't see, as they said B is the x-intercept. Anyways, show that k equals 1/3. How are we going to show that k equals 1/3? We can show that k equals 1/3 by substituting a point that lies on SA. So 3.1. We already have the y-intercept. We can solve for k. So y equals kx plus 3 at the coordinate A, which is 3 and 4, because that point A lies on this equation, right? AB, the equation of AB is kx, so A lies on this line. So y value is 4, k times 3 plus 3, you can take the 3 over and divide by 3, therefore k equals 1/3. I hope you guys understood that. Moving on to the next question, pretty simple so far, right? Calculate the coordinates of B, the x-intercept of the line AS. So now we know that that's the x-intercept. So 3.2. Remember, that's the x-intercept here, point B. So now we have y equals 1/3 x plus 3. To find x-intercept, you're going to make that equation equal to 0, right? Making y equal to 0. So we got 1/3 x is equal to -3. Multiplying both sides by 3 gives me x equals -9. So the coordinates of B is -9 and 0. So let me write down -9 here. Right, so problem solved. Let's look at the next question. Calculate the coordinates of C. Let's find the coordinates of C. How are we going to find the coordinates of C? Remember, that's the endpoint, because remember they told us that F is a midpoint. Now since F is a midpoint, is also the y-intercept. So we already have the midpoint, which is 0 and -2. Where we got the -2 from? From here, the y-intercept of this line. F is the y-intercept. Now, so you can make C, coordinate of C, as AB, right? Now if you add up the endpoints of this line divided by 2, you're going to get 0. So A plus 3 divided by 2 is equal to 0, 3.3. So A plus 3 divided by 2 is equal to 0. So A is equal to -3, cross multiplying and then taking the 3 over. I hope you guys understood that. So remember, coordinates of C, the value of A is -3, and the value of B is B plus 4 divided by 2 is equal to -2. Multiplying both sides by 2 is going to give me B plus 4 is equal to -4. Taking the 4 over, you're going to get B is equal to -8. Therefore, C is now -3 and -8. So I can take out A and B and put -3 and -8. -3 and -8. Okay, so I hope you guys are understanding. They always ask these types of questions where the midpoint is given, you need to find the endpoint. So nothing out of the ordinary. Alright, let's move on to the next problem. Determine the equation of the line parallel to BC. Right, so I need to explain this to you, so let me just copy this for you and explain what's happening. So retake this again. So retake again. Right, so let's understand what this question means, because it's 5 marks. We can't play around with this, right? So determine the equation of the line parallel to BC. It needs to be parallel to line BC and passes through the point S, which is -15 and -2, and passes through the point S, parallel to BC and passes through the point S, which is -15 and -2. Remember, what's the point S? Point S is -15 and -2. But now remember, we can find the equation of BC because we got a point, we got 2 points on BC, which is -9 and 0, right? So let's find the equation of BC. Not the equation, let's find the gradient of BC, right? Because we want to find the equation of this line over here, which is parallel and passes through the point. Remember, it's parallel to BC. Change the color of this line, alright? Alright, so what we're doing is we're trying to find the equation of this line, right? It passes through the point S. So because it's parallel, remember parallel lines have the same gradients. So first we're going to find the gradient of BC and transfer that gradient here and then passes through the point S. So what's the gradient of BC? Gradient of BC is BC, so minus 8 minus 0, y2 minus y1, alright? y2 minus y1 over x2 minus x1. X2 is minus 3 minus minus 9, so plus 9. So what I've got is negative 8 over 6, which is minus 4 over 3. So the gradient here, so the gradient of gradient at S is also equal to minus 4 over 3 because we have parallel lines. Right. Now we're going to use this equation y minus y1 equals m into x minus x1 at point S, which is negative 15 and negative 2. So there's your x value, there's your y value. Put it here. That's x1, that's y1. Put it here. So y plus 2, m is negative 4 over 3, x plus 15. Now open up this entire equation because we want it in the form y equals mx plus c. So y equals minus 4 over 3x, minus 4 times 15. 3 and 15 can cancel out 5 times. 5 times minus 4 is minus 20 and minus 2. So I just want to check this out. Minus 4 over 3, minus 4 over 3. Again, minus 4 over 3 times 15. So what am I getting? I'm getting negative 20, and take the 2 over negative 20. So we will get negative 22. So minus 4 over 3x minus 22. That's the answer. Right, so we got the equation of this line as well. Next one. Calculate the size of angle BAC. What is the size of angle BAC? BAC. So we want the size of angle A, alright? Now at angle A, right? At angle A, the vertex, line BA is meeting up and line AC is meeting up. So all we need to do is calculate the gradients and the angles of inclination. Now at angle A, what's happening is line AB and AC are meeting up. So what's the gradient of line AC? It is 2. So we're going to say tan alpha equals 2. Alpha equals shift tan 2. Right, so alpha equals 63,43 degrees, and the other angle I'm going to call beta here, right? And then we can do exterior angles of triangle. So this one here, line, what's the gradient of this line? It was 1/3. Remember the value of k. So tan beta is equal to 1/3. So beta equals tan inverse 1/3. What's the answer? We need to put 1/3 in here. Right, so I'm getting an answer of 18,43. Therefore, angle A or BAC is now equal to, we can use exterior angles of triangle. So that's an exterior angle, right? And that's the sum of those two angles. Or just take big angle minus small angle whenever you want to find the angle at the vertex. So 63,43 minus 18,43, because I'm doing exterior angles of triangle BAC, right? Now we can solve. What is 63,43 minus 18,43? 63.43 minus 18.43. I've got an answer of 45 degrees. Perfect. So we know that angle is 45 degrees. So we know angle A is 45. Right. Now moving on, each of these questions are 5 marks each towards the end. Crazy. That's a lot. Let's copy this and put it here, because I need to explain this to you, what area we're calculating. So we want to go and calculate the area of triangle ABD, area of triangle ABD, right? So that's the first triangle ABD over the area of triangle ASC, ASC. Let me join a line from S to C. Okay, what can we do? Can we do a common height, half base times height, ASC, ASC. Area of triangle, area of this small triangle here, that's easy. What's the area of triangle ABD? Area of triangle ABD is equal to half base. What's the base? BD is the base times the perpendicular height. And I can get a perpendicular height here, right? If I draw a vertical line here from A to the x-axis, okay, so I kind of have a perpendicular height here, which is 4. And what's the base? BD is the base. BD, ABD, yeah, BD is the base from -9 to, what's the x-intercept here? Isn't we got the equation of this line? If we have the equation of this line, the x-intercept is 2x minus 2 equal to 0. This implies x is equal to 1. So I've got the x-intercept, which is 1. So from -9 to 1, the distance is 10. So I've got half base times height. Half, right? Base is 10 and the height is 4. Right? So I've got 40 divided by 2, which is 20 units squared. Now I've got the area of this triangle. Now the problem is to find the area of this triangle here, ASC. Now to find the area of this triangle is difficult to find the perpendicular height. So what I'm going to do is I'm going to use this angle and the distance of AS and the distance of AC. So I need to calculate the distance AC, which is the square root of, and we're going to use the sine formula, right? Half AB sine C, that formula. So what's the distance of AC? The distance of AC is -3 all squared plus -8, distance formula guys, y2 minus y1, x2 minus x1 all squared plus y2 minus y1 all squared, -8 minus 4. Right, so I'm just going to put this into the calculator. So that is square root of, that's -6 squared, which is 36, plus that's the square root of that is 12 squared, 144. Right, so I'm getting 6 root 5. And the distance of, I just calculated AC, right? I need to calculate the distance of AS. S was -15 and -2. AS, distance AS, -15 -2, that's what it was. Let me just, -15 -2 was the distance, was the coordinate of S. So AS, I'm going to calculate the distance, square root, and we're going to say -15 -3 all squared plus -2 -4 all squared. Right, so I'm just going to enter this whole thing in the calculator again. Square root, that's -15 18 squared plus, I know that is 6 squared, which is 36, and that is 6 root 10, right? And now the area of triangle ASC, area of triangle ASC is equal to half AS is 6 root 10, and AC, which is 6 root 5, sine 45, right? And we know sine 45 is a special angle, which is 1 over root 2, but we're not going to do that. We're just going to take the ratio. Therefore, ratio of the area, okay, let's work out this area here, insert form. So what do we have? We have half, right? 6 root 10, close bracket, open, 6 root 5, close bracket, and then sine 45. And am I getting 90? Right, so I've got an answer of 90 units squared. So therefore, the ratio of these areas, you need to write it down, okay? You need to write down the area of triangle ABD over the area of triangle ASC is equal to 20 over 90, which is equal to 2 over 9. I hope you guys understood that. Right, let's move on to question number 4. Question number 4 says, in the diagram, the circle centered at C, remember C is a circle center, is drawn. A is 5, 1 and B is minus 3, 3 are points on the circle. E is a midpoint of AB. Now very important, because it's a midpoint, those two lines are equal. Now that's a circle center. So if you draw a line from the center of the circle to the midpoint of a chord, remember that is perpendicular. So very nice circle theorems there, right? So we know that this line is perpendicular. Right, so we know that line is perpendicular. Why? Line from center, midpoint of chord is perpendicular. Right, so now we got that to be perpendicular. Perfect. Now, first question. Calculate the coordinates of E, the midpoint of AB. So let's calculate it here, 4.1. Coordinate of E is 5 minus 3 divided by 2. Adding the 2x values dividing by 2. Add the 2y values divided by 2. So 1 minus 3 divided by 2. So that is E. What's the coordinates of E? That's 2 divided by 2, which is 1. X value is 1. Y value should be negative. Minus 2 divided by 2, so negative 1. 1 and negative 1. I hope you guys understood that. Next question. It's just 4 marks. Determine the equation of the perpendicular bisector of AB in the form y equals mx plus c. So 4.3. Determine the equation of the perpendicular bisector of AB in the form y equals mx plus c. Equation of the perpendicular bisector is this line that I drew here. Remember, in the form y equals mx plus c. Well, we need the equation of this line first. Equation of AB, a gradient of AB. Gradient of AB is y2 minus y1, so minus 3 minus 1 divided by minus 3 minus 5. So I've got minus 4 over minus 8, which is basically half. So the gradient of EC, right, or the gradient of the perpendicular bisector, let's just call it gradient perpendicular. So upside down T, right? So gradient perpendicular will be opposite sign, minus, and flip this around, or reciprocal this, negative reciprocals, so negative 2. Now we got negative 2 and we got the point E, right? Perpendicular bisector, so the line needs to go perpendicularly to AB and it needs to bisect. What does perpendicular bisector means? It must be perpendicular to line AB and it must bisect Bisect means to cut in half, so it goes through E. So we're going to say at E, which is 1 and minus 1. So we're going to use this equation, y minus y1 equals m into x minus x1. So y minus y1, minus minus 1 is plus 1, m is minus 2 into x minus x1. x1 is 1. Remember, this is x1, that's y1. Now we're going to open this up. We're going to get minus 2x plus 2 and take this 1 over, so minus 1. So what's the equation? Therefore, y is now equal to minus 2x plus 1. And basically, that has to pass through the center of the circle because that's perpendicular and that's, you know, that's a chord. Show that P is equal to 3. Very easy to show that P is equal to 3. We got the equation of line EP, y equals minus 2x plus 1, y equals minus 2x plus 1, right, at C, which is 2 and P. So the value of y is P, that's minus 2 times 2 plus 1, and that's minus 4 plus 1, which is negative 3. I hope you guys understood that. Right, so the value of P is 3, negative 3. Next question. Show by calculation that the equation of the circle is x squared plus y squared minus 4x plus 6y minus 12. Well, we have the center. Center is 2 and minus 3. Remember, we just found P. Center of the circle is 2 and minus 3, the value of P. Okay, let's copy this diagram and put it there. Alright. Now look at the circle on this side. Right, so we got center. We need the radius. How are we going to find the radius? Easy to find the radius. We just draw a line from the center of the circle to this and use the distance formula, right? Because we got the value for P, right? Let's take out all these lines here. Right, so we got the value of P, which is negative 3. Oh, we just figured something out. Look at this. This is actually a horizontal line because it has the same y value. Watch here. So it's easy to find the radius. That's negative 3 and that's negative 3. So we are going from x value minus 3. So horizontal line is drawn like this. Alright, so remember the distance from here to there is 3 x values and the distance from there to there is 2. So the radius is 5. Right, so radius is equal to 5. So what's the center radius? So we're going to say x minus 2 all squared plus y plus 3 all squared is equal to 5 squared. Now open this entire equation up. We got x squared minus 4x plus 4, squaring a binomial, y squared plus 3 times y is 3y times 2 6y, square the 3 9, bring the 5 over, minus 25 is equal to 0. Bring the 5 squared over. Now we have x squared plus y squared minus 4x, right, plus 6y. Now plus 4 plus 9 is plus 13, minus 25 is minus 12, which is equal to 0. So I showed that, right? So I hope you understood that. Very nice question, guys. And the last question, calculate the values of t for which the straight line y equals tx plus 8 will not intersect the circle. What are we doing here? Let's try to explain this with the diagram. Right, 6 marks, so we can't play here. It's a difficult question, right? It's level 4, so we have to think about what we need to do here. Right, so will not intersect the circle. it will not intersect the circle. So we have an equation here, y equals tx plus 8, and what if it does intersect the circle? Let's check. Y equals tx plus 8, and we have a second equation, which is the equation of the circle, right? So that's the equation of the circle here, right? Remember, I just copied that. I don't want to rewrite this. Now we got y equals tx plus 8, right? Take y equals tx plus 8 and substitute it here. I think the method that I'm going to use, which is coming to my mind, is basically I'm going to try and use nature of roots, because I will get an equation in terms of x, and if I say delta less than 0, then I will get non-real roots, which means that I will get some values of t, and then I will double check if that values of t actually works. Right, now let's check. We got x squared plus y squared minus 4x. So we know what the value of y is. We know the value of y is tx plus 8. So let's write this out. We got x squared plus tx plus 8 all squared minus 4x plus 6 into tx plus 8 minus 12 is equal to 0. So I have a quadratic here, right? So all I've done is I've substituted the value of y inside this entire quadratic formula. Alright, so let's solve this. We have x squared plus t squared x squared. I squared this. The product of these two times 2, you're going to get 16tx. 8 squared is 64. Right, so far I've just managed to expand that. I need more space here, right? Let's move this one side. Minus 4x plus 6tx plus 48, 6 times 8 minus 12 is equal to 0. Right, so I want to add up all the coefficients, all the constants. 64, 48, minus 12. Those are all the constants I have. So if I add up all that, I've got 64 plus 48, 64 plus 48 minus 12. I've got 100. I've got plus 100. Now let me look at all the x squared terms. So I've got an x squared here. That's the only x squared I've got. I've got t squared x squared here. Okay, so the x squared terms, let me factorize that. So I'm going to take out x squared as a common factor, left with 1 plus t squared. So I'm done with the x squared terms, okay? Next, I need to look at the tx. What am I left with? I'm left with the 16tx and the 6tx. Right, so 16tx and 6tx, that makes 16 and 6, that is 22tx. Alright, I can take out x as a common factor. Alright, I'm taking out x as a common factor from this as well. So I've got 22tx minus 4. So I'm trying to collect all the x terms. So obviously those were like terms. So that makes 22tx. So there's it here, 22t times x, 22tx minus 4, because I took out the x. Now I've got a, b, c values. A equals 1 plus t squared, right? B equals 22t minus 4, and c equals 100. Now I'm going to find delta. If I find delta and find the values of t for which it is non-real, then yeah, I'm going to find values of delta for which delta is non-real. So delta is equal to b squared minus 4ac. B squared will be 22t minus 4 squared minus 4. A is 1 plus t squared, and C is 100. Now 22, let's see, 22 squared is 484 t squared. 22 times 4 times 2, 22 times 4 times 2, that is 176. So negative 176t plus 16, right? And then we got minus 400, because remember I'm collecting this. Minus 4 times 100 is minus 400 times 1, and then minus 400 t squared. Right, so I hope you guys are understanding. Now let's simplify. We got a nice quadratic here. Very difficult, guys. Right, so 484 minus 400 is 84t squared minus 176t and 16 minus 400 minus 384. So I can factorize this. I can take out what as a common factor? Can I take out 4 as a common factor? 84 divided by 4, getting 21, maybe 12. 84 divided by 12, can take out 12 as a common factor, yeah. So let's take out 12. So I'm left with 7t squared. 176 divided by 12, 176 divided by 12. I've got, no, I think I'm just going to take out 4 as a common factor. I need to check if this here factorizes. Mode 5 3. Let's see what this here factorizes into. We got 84 minus 176 and 384 minus 384. Yeah, so it does factorize. So it's factorizing into 7 and 3. That's 21. So I can only take out 4 as a common factor, guys. So I can take out 4 as a common factor here. So I've got 21t squared minus, what is 176 divided by 4? I'm getting 44t minus 384 divided by 4. 384 divided by 4, I'm getting is 96. So I can factorize this into 4, open 2 brackets. So I'm going to use mode, otherwise you have to use the quadratic formula to solve, factorize this, or find some other techniques. Right, so mode 5 3, I've got 21 minus 44 and minus 96. So I'm getting 7 minus 24 here and 7t. So I must get 3t here, right? 3t plus 4. Right. Now what do we do with this delta? What do we do with this delta? We need to make it, if it's equal to 0, then we're going to have tangents. In other words, if delta is equal to 0 here, you're going to have this line to be a tangent to this point. It will not intersect the circle. When will this not intersect the circle? If it's equal to 0, then it will intersect that circle at one point. If it's greater than 0, it will intersect the circle. But if it's less than 0, remember, we need to solve delta less than 0. Then you need to draw a line and solve this, right? So that's minus 4 over 3, and this is 24 over 7, right? Minus, yeah, 24 over 7. So that's plus, minus, plus. If you take any value after 24 over 7, then you will get like the number 10. Substitute here, positive, positive. So positive, negative, positive. And the answer that we're looking for is in between. So the answer we're looking for is minus 4 over 3 to 24 over 7. Right, so what's your answer? Right, so that's the answer I've got. Minus 4 over 3 less than t. These are t values, right? Not x values. Then 24 over 7. So you will never find a point of intersection, right, if the value of t is in between minus 4 over 3 and 24 over 7. Sure, difficult question, guys. I hope you guys are understanding. Now we move on to question 5, which is trigonometry. If sine 40 degrees is equal to p, write each of the following in terms of p. So how are we going to do this? We know sine 40 degrees is equal to p, so it's a triangle question. So we're going to draw a triangle, right triangle, right? So let's move this here in the side, and we're going to use this triangle because it's equal to p. It's going to be p over 1, right? Opposite over hypotenuse. That's what sine is. And it's not a quadrant diagram because there's no further information given. Just sine 40 degrees is equal to p. So 40 here, right? 50 on the top, and p is opposite over hypotenuse. Remember, that's p over 1. So p and 1, and the adjacent will be 1 minus p squared using Pythagoras. Now let's write sine 220. Sine of 220 degrees is in the third quadrant. How we know that? Because that's sine of 180 plus 40, right? And that can reduce into negative sine 40 degrees because sine in the third quadrant, cast diagram, is negative in the third quadrant, right? It's 180 degree line is here. Now negative sine 40 is negative sine, what is sine of 40? P over 1, so it's negative sine p. I hope you guys are understanding. Let's move on to the next one. What is cos squared 50 degrees? Cos squared 50 degrees, we know what is cos 50. So look at the reference angle here is adjacent over hypotenuse, so p over 1, cos squared 50. So that's going to be squared, and cos of 50 is 50 degrees adjacent over hypotenuse, so p squared. So it's just p squared. I hope you guys are understanding. Right, simple question so far. Let's check what's the next one now. Cos of negative 80. What is cos of negative 80? Remember, we have a cos negative angle, right? And cos negative angle becomes cos positive. That is cos 80 degrees. First step. Second step, 80 degrees is double angle. Cos, you need to put it in terms of angles of triangle, so that's 2 times 40, right? And we can use the formulas 2 cos squared 40 minus 1. So you got 3 different formulas for, it doesn't matter which formula you use, you're still going to get the same answer. You can use any one you like, right? So 2, what is cos of 40? Adjacent over hypotenuse, so that is the square root of 1 minus p squared minus 1. So what we have 2 into 1 minus p squared, squaring a square root falls out, minus 1. And you can simplify this, right? So that's 2 minus 2p squared minus 1. That's going to give me 1 minus 2p squared. So we should have just used 1 minus the sine formula, or we could have just used from here, we could have just used the sine formula, which is 1 minus 2 sine squared 40 degrees, right? So that's 1 minus 2, we know what is sine of 40, p over 1, so that's 2p squared, right? So same answer in both the cases. Let's move on to the next one. In 5.2 we are given this long sum here. Prove the above identity. If we want to prove the identity, we're going to say left hand side is equal to, what is tan x? That is sine x over cos x into 1 minus cos squared x, right, plus cos squared x. Okay, let's see what we have here. So we need cos x as the LCD, right? So this entire thing constitutes as a single term. So just going to make this over 1. So if you take LCD, the first part remains the same. All I am doing on the numerator is opening this up, right? So I've got sine x minus sine x. Should I change this into sine x cos squared x? Sine x cos squared x all over cos x. That's what I have for that. And for the second part, I'm going to have plus cos cubed x. Why? Because I'm multiplying by cos x over cos x. Now I've got the LCD. I got the same LCD as this one. Now we got to play around with this to get it into that form. So we got sine x plus cos x into 1 minus sine x cos x. So how does this factorize? So we got sine x cos squared x. We got 1 minus cos squared. We should have changed the 1 minus cos squared to sine squared. So we could have got sine cubed plus cos cubed. But that's not going to be helpful because we got sine x. If I open this up, I've got sine x sine squared. I'm getting sine x sine squared. Unless we change the cos squared x into 1 minus sine squared. Let's see what we can do here. I think we're just going to leave this part. Let's just leave this. Alright. So let's change this one now. This is sine x and 1 minus cos squared is sine squared x. It's an identity, right? So what we got, sine cubed x plus cos cubed x. Now this is basically factorization for sum and difference of two cubes. So it's a sum of two cubes. Now you know, just in the side, a cubed plus b cubed is equal to a plus b, factorization of cubic function, a squared, squaring the first term, minus ab plus b squared. So that's what we're going to do. So that's how we're going to factorize this. Let's factorize. Right, so sine x plus cos x into, square the sine, you get sine squared, right? And then you got sine x cos x, an opposite sign, so minus sine x cos x, right? And square the cos x plus cos squared x. Perfect, guys. Now we can see the answer because sine squared plus cos squared is now equal to 1, right? So I'm just going to highlight this for you, right? Oopsie, right? So you just highlight this. We got sine squared plus cos squared, that's 1, and that's all over cos x. Now let's solve the next part. So we got sine x plus cos x, right? Sine x plus cos x into sine squared plus cos squared is 1 minus sine x cos x all over cos x. So I hope you guys understood that. A very nice problem. After long I'm seeing this, right? So is equal to right hand side, right? So something nice, very nice. So I'm just going to asterisk this because this is more like a level 4 type problem. Let's move on. Or alternatively, if you come to this stage, you can also reduce the right hand side and come to the same stage as well if you can't factorize. So you can prove both left hand side is equal to this and the right hand side is equal to the same identity. Right, let's move on to the next problem. For which values of x in the interval minus 180 to 180 will the above identity be undefined? For which values of x? Now we want values of x. So obviously on the left hand side we got tan x. So tan x will be undefined uh, tan x is equal to sine x over cos x. So we just have cos x in the denominator. So we can just say when cos is 0, right? And on the right hand side we also have cos x in the denominator. It will be undefined when cos x equals 0. Cos x is equal to 0. And when is cos of x equal to 0? If you observe the graph of cos x, when is cos graph equal to 0, right? I'm going to draw the graph from both sides. So we know we starting at 1, dropping down, right? So I'm only drawing till here, right? Cos x is 0 here at negative 90 and at 90 degrees. So answer for x is equal to 90 degrees or x is equal to negative 90 degrees. I hope you guys understood that, because we only want an answer between minus 180 and 180, and you can see cos x at that's minus 180 is negative 1. We want 0 because we want undefined. So undefined if x equals 90 or x equals minus 90, because cos of 90 is 0, cos of negative 90 is 0. Even over here, tan x, you can look at the asymptotes of tan, positive and negative 90. Right, so I hope you guys understood that. Let's move on to the next one. Question 5.3 is 6 marks. So without the use of a calculator, simplify the expression given above to a single trigonometric ratio in terms of cos 2x. So we want to simplify it in terms of cos 2x. Right, so let's see, sine of 150. So the answer is equal to sine 150 is in the second quadrant, so that becomes sine 30. 180 minus 150, sine 30. Cos squared x minus 1. What is cos squared x minus 1? Plus cos squared x minus 1. Okay, what is cos squared x? That is sine squared 1 minus sine squared, right? 1 minus sine squared x. Okay, let's just leave it like that for now. Oh yes, I wanted to cancel out the minus 1. I wanted to cancel out the minus 1. So let's replace the cos squared x with 1 minus sine squared, right? And put a minus 1 here all over 2. So what I've got, sine 30 is half. Let's take this half out of the bracket, right? And let's work with the sine 30 only. So sine 30 is half, right? And let's cancel out the plus 1 and the minus 1, right? That cancels out. So I've got half minus sine squared x. Now how are we going to simplify this? Half minus sine squared x. Right, so this here looks like is in the form of okay, we can take LCD here, right? LCD is 2, so put this over 1, right? So I've got half into 1 minus, remember this is over 2, LCD is 2, 1 can go into 2, 2 times sine squared is 2 sine squared x, right? And 1 minus 2 sine squared x is cos 2x, and half times half is quarter. Quarter, what is 1 minus 2 sine squared x? 1 minus 2 sine squared x is cos 2x. So I hope you guys understood that. Sometimes they ask you what's the maximum and minimum value of this. They can even ask you a question, what is the max value of this? So the max value of this is quarter. What's the minimum value of this? Negative quarter, because it's a number in the front that determines the range and the amplitude. Let's move on to the next question. It's 5 marks. Determine the general solution of. Now we already simplified this into quarter, right? We already simplified this into quarter cos 2x. So we got quarter cos 2x is equal to 1 over 25. Right, so I'm going to multiply both sides by, no, let's take multiply both sides by 4. So I've got 4 over 25, and this is cos 2x multiplied by 4, right? So quarter times 4 is 1, cos 2x equals 1. Right, so now we want to find the general solution, so we're going to find a ref angle. Reference angle is cos inverse 4 over 25, and that's equal to, what's cos inverse 4 over 25? I'm just going to pop my calculator quickly, right? Because we want to find what's cos inverse 4 over 25. Mode 1, shift cos 4 over 25, right? And that's equal to 80,79 degrees. Now we want to know when is cos positive. Cos is positive in the first quadrant and the fourth quadrant. So quadrant 1 solution is, remember what is the reference angle, is the 2x. So 2x is equal to 80,79 degrees plus K360, the period of cos, where K is an element of integers. Now simplify this. Therefore x is equal to 80.79 divided by 2. So I'm going to take that and divide it by 2. Divided by 2, I'm getting 40,40 plus K180, because 360 divided by 2. Or quadrant 4 solution is 2x is equal to 360 minus 80,79 degrees plus K360, right? Cos is positive there as well. So therefore x is equal to, what's 360 minus 80,79? 360 minus 80.79, that's our answer, alright? 279.21, then divided by 2 to get 139.61 plus K180. Lovely guys, I hope you guys are understanding. Let's move on to the next question, which is trig graphs. In the diagram, graph f of x, which is cos x plus a, remember cos graph is shifted. Now how is the cos graph shifted? Remember I drew the cos graph for you before. So if you imagine the cos graph, remember I drew the cos graph somewhere, right? So I drew the cos graph here, right? So let me just copy this. Now if you imagine the original cos graph, right? Right, so this is the cos x graph turning at 1 and minus 1, right? So this is the original cos graph 1, and that's negative 1 here, right? And now how is the cos graph shifted? We can see it's shifted to the right because the maximum is here at 45 degrees. So if you shift it to the right, we say minus 45. So the value of a is minus 45. So in the diagram, f of x is cos x plus a, g of x is sine 2x, and the amplitude is both 1. You can see the number in the front of cos and sine is just 1. Are drawn for the interval minus 180 to 180. Alright, the graphs intersects at minus 75 degrees and k. Minus 75 and k, it intersects there. P is 45 and 1. Q is 165 and k. It's kind of symmetrical from there to there, right? P is also a turning point of both the graphs. P is a turning point on both the graphs, right? Lovely. Write down the period of f. The period of the f graph. What's the f graph? F is a normal cos graph, right? And the coefficient is 2 there, is 1 there. So the period of f graph, you can see the entire cos graph. This is half a wave, that's quarter, and that's another. Yeah, you need to look at the minimum and the maximum. Yeah, so the period is 360, right? Because it's just a normal cos graph. So 360 degrees is a period. Write down the amplitude of g, because all we're doing with the cos graph is just shifting it left and right, the original cos graph, right? So that's why the period is 360. Unless you have a cos 2x graph, then the period will be 360 divided by 2. Okay, so far the period is just 360. Anyways, the amplitude of g, remember the amplitude of g is just 1, right? Write down the value of a. Remember what we said, the value of a will be positive 45 or negative 45. It's shifted to the right, so it will be negative 45. The value of a is negative 45. Right, so I hope you guys are understanding. Example, if I put cos x plus a. See, cos, if I put cos let's take this point 45, and I chose the value of A as plus minus 45, right? So C, cos of 90, basically I'm getting cos as 1. At 45 degrees, x value 45, I'm getting 1, so my answer is correct. Whereas if you choose cos, if you choose 45 plus 45, then your answer will be wrong, because value of A is not 45, it's negative 45. You're going to get 0, but the value is actually 1. Right, so I hope you guys are understanding. Right, so let's move on to the next question. See what the next question says. Calculate the value of k, the y coordinate of n and q, without the use of a calculator. The y coordinate of n and q. Alright, so this value, this point here we want to find, alright, the value of k. The value of k here. It looks like the value of k is half, but let's check if that is true. Remember, point n is touching both the graphs. Right, so what we can do is, remember, f of x is equal to g of x at that point. So we can say g of x equals sine 2x. Right? G of x equals sine 2x at, take one of the points, either n or q, at, let's take point q because that's a positive point, at q, which is 165 degrees, and k, right? I'm choosing a point q. So remember the value of this is the y value, so g of x is the y value, right? It's like y equals, so y is k, right? And sine 2 times 165 degrees. Now what's 2 times 165? 2 times 165 is 330, right? So sine 330 degrees. But now 330 degrees is in the fourth quadrant, right? So we need to use a reduction for this. We can say this is sine negative sine 30, and sine of 30 is half, so negative half. I told you that value looks like as if it's half, right? So but it's negative half because it's below the x-axis, right? So that's minus half. So we know the value of k, which is minus half. I hope you guys are understanding. Right, let's move on to the next problem. Question 6.5. Calculate the value of x if g of x plus 60 is equal to f of x plus 60. Now, what happens when you're adding 60? You're actually moving the graph. You're moving the graph to the left, right? And f of x is moving to the left as well. So both the graphs are moving towards the left. G of x plus 60 equals f of x plus 60 between minus 45 and 0. So we're moving this entire graph to the left, 60 degrees to the left, this entire graph. Alright, and we want to find the points of intersection. Alright, so f of x equals g of x. We want to find the points of intersection, so we're moving this entire graph to the left. So that's going to go out of the interval. Right, now we're moving this points of intersection. So see that one, if you move 60 degrees to the left, it's not going to be any close to 0. But if you move this to the left 60 degrees, so you're going to say 45 minus 16, 45 minus 60. So you're going to say 45 degrees because that's also a point of intersection, right? So x equals 45 degrees minus 60 degrees, because what is 45 degrees? It's the current point of intersection, and you're moving 60 degrees to the left. So we're getting negative 15. Now I want you to check if the values are the same. So I want you to substitute g of x plus 60, where the value of x is minus 15. So you're going to get 45 here, minus 15 plus, so g of 45. I want you to find g of 45. If I find g of 45, 2 times 45 is 90, sine of 90 is 1, so that works out. Alright, g of 45, yeah, because it's x plus 60, x value is minus 15, so that's right, right? And the next one is, I want you to find x plus 60, put 15 degree minus 15 here, so f of 45. F of 45 will be cos 45 minus 45, which is 0. Yeah, so this works out, minus 15. So basically if you move this coordinate 60 degrees to the left, if you move this point 60 degrees to the left, then you're going to end up at negative 15 and 1. Right, so I hope you guys understood that. Moving on to the next problem. Without using a calculator, determine the number of solutions. Determine the number of solutions, the equation that has which is in the interval minus 90 to 90. Clearly show all working. Yeah. So how are we going to solve this? We got root 2. We have to modify this somehow to relate it to trig graphs. Right, so we got f of x as cos x minus 45. Let's write down f of x and g of x in the side. F of x is equal to cos x minus 45 degrees, and we had g of x, which is sine 2x. Right, so those are my functions. Now I can already see sine 2x here. I can already see sine 2x over here in this equation, so I'm going to leave that as g of x. Right, so I'm going to divide everything by root 2. So I've got root 2 sine 2x equals sine x plus cos x. Now I'm going to divide everything by root 2. So I'm going to get sine 2x equals 1 over root 2 sine x plus 1 over root 2 cos x. Right? In other words, I'm just multiplying by 1 over root 2 on both sides. Now I've got sine 2x is equal to, what's 1 over root 2? Remember, 1 over root 2 is a special angle, so we can write it as sine 45, right? Sine x. We can write this as cos 45 and cos x. So what do we have? We have cos, sine with plus. So that's basically the expansion of this. So that is just basically cos x minus 45. So now expand cos x minus 45, you're going to get cos x cos 45, there's it here, plus opposite sign, sine x sine 45. Right, so we basically modified it to this. So this is basically g of x equals f of x. Right, so g of x equals f of x. We're basically finding the points of intersection, and we want to know how many points of intersection, how many solutions. Determine the number of solutions. So how many solutions between minus 90 and 90? Between minus 90 and 90, how many solutions are there? So let's check. Between minus 90 and 90, there's minus 90 here and 90 degrees. How many points of intersection are there? There's 1 here and 1 there. So what's the answer? 2. So what we're going to write? Number of solutions 2. Determine the number of solutions of the equation. They didn't say must determine the solution. So determine the number of solutions to the equation that's in the right. So number of solution is 2. And if you write down the solution, and you can also say solutions are x equals minus 90 to 90, right? So at minus 75 and 45, minus 75 and 45, and 45, minus 75 and 45 degrees. Well, they didn't ask for this, they just asked for the number of solutions, right? So I'm just gonna asterisk this. They didn't ask for this, they just asked for that. We're just writing extra. Remember, it's always good to write more than to write less. Right, now let's look at the next question. In the diagram, triangle ABC is drawn. AD is drawn such that AD is perpendicular to BC. So all the information here is given. It's a right angle triangle. Use the diagram above to determine AD in terms of sine B. So now if I ask you what is sine B, using AD, sine B is opposite of a hypotenuse. So you're going to say 7.1.1 sine B is equal to AD over AB. So what did they want? They wanted AD. So what is AD? This implies AD is now equal to cross multiply AB sine B. What do I mean by cross multiply? There's a 1 here. 1 times AD is AD, sine B times AB is AB sine B. I hope you understood that. Next one. Hence, prove that the area of triangle ABC is half BC AB sine B. Half BC AB sine B. What's area of triangle? Very simple. What's area of triangle? Area is equal to half base times perpendicular height. What's the base? Base of this triangle is BC. We got half BC, half base times that. Why did I write capital B? It's a small b. Alright, so half BC. What's the height? Height is AD. And what is AD? AB sine B. Sine B. Right, so you can write it out like this as well. So that's half BC AB sine B. So we proved it. Perfect. Let's move on to the next problem. Right, so next problem, we have a diagram here and we want to prove that AD equals AC. In the diagram, points BCD lie in the same horizontal plane, is usually shaded, right? ADB and ACB is equal to alpha. ADB and ACB is equal to alpha is given. CDB is equal to theta. CDB, B is not, B is right here, okay? That's B. CDB, CDB, angle D, alright, so this angle there is theta, okay? And DC is equal to K units. DC is K units, right? And BD equals BC. BD equals BC. So those are equal, right? So I hope now, obviously, if those are equal, then this angle C over here will also be theta. Angles opposite equal sides. Now prove that AD equals AC. How are we going to prove that AD equals AC? AD equals AC is 2 marks. Right, so how are we going to prove that AD equals AC? AD equals AC. AD is equal to AC. Let's write AD in terms of theta here. So we can say AD in terms of theta and side BD. So we got adjacent hypotenuse. So we can say cos alpha equals BD over AD, right? So this implies AD is equal to BD over cos alpha. I'm just switching positions, right? Bring that down, take that up. AD is equal to BD over cos alpha. And the next one we can say cos alpha here as well is equal to BC over AC. Right, so I'm going to switch position as well. So AC is now equal to BC over AC. So AC is now equal to BC over cos alpha. But we know that BD equals BC. BD equals BC. So we can replace this BD with BC. So AD is equal to BD over cos alpha. No, let's replace this with BC. Remember, BD is equal to BC. This is given. So we're going to say BC over cos alpha, and AC is also equal to BC over cos alpha. This implies AD is equal to AC. I hope you guys understood that. So we know that AD is equal to AC. Perfect. Next one. prove that BD is equal to K over 2 cos alpha. Prove that BD, we want to find BD is equal to K over 2 cos alpha. Now K over 2 cos theta. So we need to use angle theta somewhere here, right? And we want BD. So if we want this line BD over here, we can use the sine rule. K over, we got the side K here. K over this angle. This angle here is, so let's write angle DBC equals, first we need to say that angle DCB is equal to theta DCB. Angle DCB is equal to BDC is equal to theta, because we have angles opposite equal sides. Right, we got angles opposite equal sides. So now angle DBC is equal to 180 minus 2 theta. Do we need to do that? Cos theta. So we want to prove BD. When you get the length BD in terms of theta, so we have to look at the horizontal plane, right? So thus the side that's given, K over sine of that angle, K over sine of this angle. So let's just find DBC. Angle DBC. Angle DBC is equal to 180 degrees minus 2 theta. That is sum of angles of triangle BCD. Right? Let me bring this diagram down. Right? So far what we have, this diagram, let's take it down and solve this. So let's solve this triangle now. Right, so 2 cos K over BD. Right, so we can say K over sine 180 minus 2 theta. K over sine 180 minus 2 theta, which is angle B, is equal to, I'm only looking at the horizontal plane, K over sine theta equals angle C. Alright, so it's going to be BD over sine theta, which is that angle C there. Right, so looking at the horizontal plane only. Now remember, if we cross multiply, we're going to get BD sine 180 minus 2 theta is just 2 theta, because that's in the second quadrant. I simplified that. Remember, I'm cross multiplying and I'm simplifying. Alright, so BD 180 minus 2 theta is sine 2 theta. That's in the second quadrant. And this is K sine theta. Right, and now we can solve the problem, because we got BD equals K sine theta. Now remember, we're going to divide both sides by sine 2 theta. Okay, so what is sine 2 theta? 2 sine theta cos theta. And now what we see is that sine theta and sine theta cancels out, and my answer is K over 2 cos theta. Right, so I hope you guys understood that. That's BD. Right, nice problem so far. Next one. Let's bring this down here in the side. Alright, let's put this in the side. Now determine the area of triangle BCD. BCD in terms of K. in terms of k and a single trigonometric ratio in terms of theta. So we have to use k, alright? So I'm going to use that angle theta here, right? In terms of k, okay, let's use this side. So we're going to use this side here. That's the information we have. I'm drawing the horizontal plane. That is B, D, C. This is K. Remember BD we just found above. And this angle is theta. So area is equal to half BD DC sine theta. Now let's solve half. What is BD? We just saw BD, K over 2 cos theta. What is DC? K sine theta. Alright. Now remember 1 times K times K. I'm going to combine these two, alright? Because sine theta and cos theta. Remember that is tan theta. So 1 second, let's just simplify everything. Okay, let's write it in terms of, let's multiply all the numerators first. Right, so 1 times k sine theta is k squared sine theta over 2 times cos theta is 4 cos theta. Sine over cos is tan. So I've got quarter k squared tan theta. What they said, determine the area of triangle BCD in terms of k and a single trigonometric ratio in terms of theta. So single trigonometric ratio is tan theta. In terms of k is k squared, and there's a coefficient in the front. So I hope you guys understood that. Right. So now moving on to the next problem, which is geometry. Right. So basically we want to prove this theorem. How are we going to prove this theorem? Obviously we're going to use constructor lines. This is the tan chord theorem. Right, so all this information is given here. You can read up. This is a tangent to circle. Prove the theorem that which says that the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. In other words, BCE is equal to alpha. Right, we see BCE is equal to alpha. So we want to prove that BCE, this angle, is equal to A, not alpha, A. So what we're going to do is, I don't have a diagram sheet here, so I'm just going to construct this line. So you must say construct line COD diameter and join BD. Right, these are your construction lines. Now usually construction lines we put it in, what do we do the construction lines? We usually put it in broken lines here, right? Now we know this is a call one of the angle X. Let's call the angle C1. Let's call it C1 C2. That is C1 C2. That's B1 B2, and that's just angle A. Now remember this is 90 degrees because tangent perpendicular to radius or diameter, and this is angles in a semicircle, and call angle C1 equal to X. Right? Now if angle C1 is X, what is angle C2? That's 90 minus X, and that's a right angle triangle. So what is angle D? X. And then you can take angles in same segment. D becomes X and A becomes X. So it's proved now. So let's write it down. So first we're going to write construct diameter COD, construct diameter COD, and join BD. Right, now the proof, that's a construction. The proof is angle DBC is equal to 90 degrees. DBC is equal to 90 degrees. What's the reason? Angles in a semicircle. Right, that's angles in a semicircle. Next, we need to say DC is perpendicular to DE. Is perpendicular to DE because we have radius perpendicular to tangent. Then or diameter perpendicular to tangent. Let's write diameter. Right, we got diameter perpendicular to tangent. Diameter perpendicular to tangent. And then let angle C1 be equal to x. So what's angle C2? 90 minus x. What's angle D? X, because sum of angles of triangle. Obviously, if this is 90, did we say angle? Yeah, angles in a semicircle, that's also 90 here. We mentioned those two. Angle C1 is x. Angle D is now x because sum of angles of triangle, okay? Sum of angles of triangle. Which triangle? DBC. Right, so far so good. And now we can say angle D is equal to angle A. Why is angle D equal to angle A? Angles in same segments, right? And this implies we got angle BCE. Angle BCE, which is angle C1, is equal to angle A, which is both equal to x, right? So we proved it. I hope you guys understood the proof. So it's kind of like just solving for x without using any tangent. So now we have the tan-chord theorem. Right, so let's apply. I'm sure we're going to be applying this tan-chord theorem, what we just learned now. Let's see. In the diagram, PQRS is a cyclic quadrilateral. We got PQRS is a cyclic quadrilateral with RQ equals to RS. RQ and RS are equal, and it's a cyclic quadrilateral. That's very important information here. Make sure you read everything. ST is a tangent. Now, if ST is a tangent, remember this angle will be equal to the angle in the alternate segment, which is angle Q1, right? Those will be equal, and you know angle Q1 is equal to angle S2 because of isosceles triangle, angles opposite equal sides. And we can see that SN bisects that angle there. Anyways, we can find all these angles because there's an angle which is on the outside. Exterior angles of cyclic quadrilateral is equal to interior opposite angles, so this is also 68. Angles on a straight line, we can find angle R1. Let's read the first question. Right? What is angle P? Angle P is equal to 68 degrees. Let's write it down. Exterior angles of cyclic quad. What's the cyclic quad? PQRS. Right? What is angle Q1? Angle Q1. Alright, we want to find this. So for angle Q1, we're going to have multiple reasons. 8.2.2. To find angle Q1, first we're going to do angles on straight line. Should we do angles on straight line? First we should say angle Q1 is equal to angle S2. Right? Reason, angles opposite equal sides, or base, and don't write base angles of isosceles triangle because the government reasons they want this. Right, angles opposite equal sides. Now we can see there is an exterior angle of a triangle here. So 68 is equal to 2 times, call it x and x. Right, let it be equal to x. So 2x is equal to 68 degrees. Why are we saying this? Exterior angles of triangle QSR. So x is now equal to 34 degrees. Remember, exterior angles of triangle is equal to interior, the sum of the interior opposite angles. Right, so x is equal to 34 degrees. This implies angle Q1 is equal to 34. Right, so we got 34 degrees here. Let me take out yeah, we should leave the x because we know x is 34. What is angle S1 now? We said angle S1 is tan-chord theorem, so angle S1 is equal to angle Q1, right? Because tangent directly opposite the chord is angle Q1, right? So angle Q1 is equal to 34 degrees, and the reason is tan-chord theorem. I hope you guys are understanding. Don't forget to comment if you don't understand. In the diagram, let's look at the next question, which is question number 9. So what we have here in the diagram, AB is a diameter. Now very important information. If AB is a diameter, remember we can fill in 90. AB is a diameter. Where's AB? AB is a diameter. Alright, let's put this in the side and then answer the question. So AB is a diameter. Right, so if that's a AB is a diameter, then we can make a 90-degree box here. Right, angles in a semicircle. Right. Then we also have with center F. F is the center, so we can mark off the radii. So we know this angle here is equal to that angle. AB and CD intersect at G. Okay, we can see the intersection point. FD and FC are drawn. FD and FC are drawn, so those are radii, we know that. BA bisects CAD, very important information. BA bisects CAD, CAD. So those angles are also equal. Right, now remember this is radii, so that's equal as well. AF equals DF equals GF. This angle and this angle, why am I putting dots here? Let's put X, X, Y, Y. X, X. Let's put Y, Y. So obviously this will be Y here. Also note that we have angle at center equals twice angle at circumference. So we should take out YY here. Let's take out the Y because we can get it in terms of X. Those two are equal. Alright, let's look at the first question now. I think we understand the diagram. Alright, so the first question is, determine giving reasons any three other angles equal to angle D1. Which angle is equal to angle D1? Any three other angles equal to angle D1. We should have worked from angle D1 rather. That's the 90 we're going to keep there. Angle D1, alright, so we have angle D1 here. We can look at chord BC, right? So angle D1 is 37. So let me take out these now because I know those are equal. It's fine. Leave this radii marked off. So angle D1 is 37. So if I look at this chord BC, it's going towards there and it's going towards angle A2. So we can write angle A2. Right, so we can write angle A2 is equal to angle D1 is equal to 37 degrees. Reason? Angles in same segments. Right, angles in same segments. Yep. Angle A1 is equal to angle A2. This is my second angle I'm finding, which is 37 degrees. Because that's angles bisected. It was given, right? Angles bisected. So we know this is 37, right? And that's 37 degrees. Now, okay, so now we have radii. We got angle C2. Angle C2 is also 37 because F is the center. Right, so angle C2. But first we need to say AF equals FC. AF equals FC. That's radii. So angle C2 is equal to angle A2, which is equal to 37 degrees. Angles opposite equal sides. Obviously I can find more, which is C3 is also 37. By saying DF equals AF radii, okay, and we can solve all that. Right, so perfect, nice question. We got three angles there already. Next one, show that DG equals GC. How is DG equals GC? DG equals GC. In other words, we want to prove that this line is perpendicular. We want to get this angle to be perpendicular. Right, so how are we going to prove that this is perpendicular? We can get angle, okay, we can get angle as center equals twice angle as circumference here. That's if you want that, but we can get angle as center equals twice angle as circumference this way, using this chord. Angle as center equals twice angle as circumference. So angle F1, let me take out this 90 because we don't know that is 90. I just drew that over there. Right, so we can say angle F1 is equal to, angle F1 is equal to 37 times 2, which is 74 degrees. Angle at center equals 2 times angle at circumference, right? So this is 74. Remember what we said, DF needs to be equal to AF radii, so we can get angle D3 to be 37, and then we can subtract the angles from the 90. So we have to say angle BDA is 90 degrees, angles in a semicircle, because we didn't use that. Angle BDA, angle BDA is equal to 90 degrees. Why are we saying angle BDA is 90? Because angles in a semicircle, angles in semicircle, right? So BDA is 90, angles in semicircle. Then we need to say DF equals AF. DF equals AF. Why is DF equals to AF? Radii. So what we can say now from this, we can say that angle D3 is equal to angle A1, which is equal to 37 degrees. Angles opposite equal sides, right? So those are the important ones, right? And now we can find angle D2 because the whole thing is 90, and that's 37, that's 37. So angle D2 is equal to 90 minus 37 minus 37. I think that's 90 minus 74. 90 minus 2 times 37. So I'm getting 16. Right, so we're getting 16 degrees. And this implies angle G1. Angle G1. Right, so I'm trying to use sum of angles of triangle now. Let's take this diagram down. Okay, so what we have now is angle G1 is equal to 90 degrees. How we got that? 180 minus D2 minus 74. Remember D2 was 16 degrees, alright? So angle G1 is 90. Sum of angles of triangle DGF. Right. Therefore, because this is 90, we got DG equals GC. This implies DG equals GC, right? DG equals GC. Line from center, right? Perpendicular to chord. Right. So I hope you guys understood that. Right. Remember that we proved that angle G1 is 90. Perfect. Nice question. Oh, there's one more. Let's take this information down here. Right, so we already know that these two lines are equal. What color can I use? Right, so we already know that these two lines are equal. That's 90. If it is further given that the radius of the circle is 20 units, calculate the length of BG. BG. To calculate the length of BG, remember BF equals AF. BF equals AF, which is equal to 20. That's a radii. Okay. We got this angle. Remember, we can find GF using trigonometry, because look at this triangle DGF. DGF. We have 16 degrees here. Remember, we found angle D2, which was 16. Right, D2 was 16. DF, we should say DF as well. These are all radii, so this is 20. So we can find GF using trigonometry, which is opposite hypotenuse. So sine 16 is equal to GF over 20. Right, so this implies GF is equal to 20 sine 16. What is 20 sine 16? Let's work it out. 20 sine 16. So I'm getting an answer of 5,51. Right, 5,51 units. So therefore, the entire BF is, remember I just found GF now. So therefore BF, no, they wanted BG. So we got BG now, because the entire distance BF is the radius, and the radius is basically 20. So what we can say now is that BG is equal to 20 minus GF. 20, because the entire distance is 20 minus GF, which is 5,51, and that's going to give me 20 minus 5.51. That's going to give me 14,49 units. 14,49 units. I hope you guys understood that. Right, so wasn't so bad so far. Right, I hope you guys are enjoying this lesson and these problem walkthroughs. Right, let's look at this question. Right, let's look at this question. Quite complicated diagram, but if you read the story, it won't be complicated. Right, so let's read the story here. Right, so let's read together and follow through. Just trying to get the diagram in order. Right, so in the diagram, COD is a diameter. COD is a diameter with center O. Since we have center O, we got radii. See, OB is a radii, OD is a radii, OF is a radii. So I'm going to mark those. Right, those are radii, but there's too many markings. Right, so just hold on. Now remember, there's a 90 degree here, because they said that is the angles in a semicircle. That's 90. EA is a tangent. EA is a tangent. So remember, angle F4 will now be equal to angle C2, because tan chord theorem. And angle C2, look at the center. Angle at center equals twice angle circumference. Angle C2 will be angle O3 will be twice angle C2. Right. AO is perpendicular to CE. AO is perpendicular to CE. Why did they give us that information? AO is perpendicular to CE. It's just a perpendicular line. Alright, so this will also make it 90 on this side. Why did they give us this? Alright, carry on. Diameter COD produced intersects the tangent to the circle at E. Alright. OB is produced intersects the tangent to the circle at A. Alright, so this entire line is a tangent, so it intersects at A. The tangent line and this radius from there to there intersect at A. CF intersects OB and T. The rest of the lines are just drawn. So the most important information we put down. So question number 1. Prove with the reasons that TODF is a cyclic quadrilateral. TODF. TODF. How is that a cyclic quadrilateral? TODF is a cyclic quadrilateral. How? Remember, we got a 90 degrees there. We can also get a 90 degree here. Remember, this is a radius and it's perpendicular to tangent. Right, so we got opposite angles supplementary. So we got this to be 90 as well. Right. Just F3, F4 is 90. Is it just F3, F4? TODF. Yes, we want to prove that TODF is a cyclic quadrilateral. So how can we prove that TODF is a cyclic quadrilateral? We're not getting 90 degrees opposite here. Are we missing any information? Okay, so that's not summing up to 90. That has to sum up to 90. F2 and F3 needs to be 90. So we need F2 and F3 to be 90. So come on guys, let's think. Right, so why is this 90? There's it here, because CD is a diameter. Right, so we got it. So we can just use exterior angle equals interior opposite angle, converse. So we can say CFD, angle CFD is equal to 90 degrees. Angles in semicircle. And now we can say TODF is a cyclic quad. Why? Converse, exterior angles of cyclic quad is equal to interior opposite angle. Right, because we got let's write it down, which is, this implies, should write one more information here. This implies angle O1 is equal to angle CFD, and both of them are 90 degrees, and that angle O1 is an exterior angle of a cyclic quad TODF. I hope you guys understood that. Alright, so I think I marked off too much of information here, but anyways, I don't need that 90 because I know that's already 90 there. That's 90. Remember, F3 and F4 is also 90 over here because it is what is it? A radius perpendicular to tangent. F is a tangent and OF is a radius. Okay, so keep that in mind. Next question. Next question, we prove that angle D3 equals angle T1. How is angle D3 equals to angle T1? How is angle D3 equals to angle T1? Is right there. Obviously we just proved that this is a cyclic quad, right? We proved that this is a cyclic quad, right? So we can say D3 is an exterior angle of a cyclic quad is equal to interior opposite angle equals angle T3, and then T3 equals T1 vertically opposite. So D3 equals T3. Angle D3 is equal to angle T3. Reason? Exterior angles of cyclic quad TODF, right? And then angle T1 equals angle T3 because of vertically opposite angles, right? This implies D3 equals T1 because both are T3s, right? I hope you guys are understanding. Perfect. So far so good, nothing difficult, right? So first two questions, easy peasy, 4 marks, 3 marks, 7 marks we've got. Let's prove the similarity here now. What similarity we got? TFO and DFE. I need this diagram down, not with so much of marking, because we got those information already. Just remember those information, right? So remember this is 5 marks, right? Let's take this in the side here, right, so you can see it on the screen. Let's solve this. We got TFO. So we got TFO. So is this first triangle TFO and DFE, and the second triangle. Okay, now let's see, in triangle TFO and triangle DFE is 5 marks, so we got to think about what to do, right? Keeping in mind all the previous information that we got. We know that angle D3 is equal to angle T3, proven above. Angle D3 is equal to angle T3. We know that angle D3 is equal to angle T3. DFE, right? Reason, you can just write exterior angles of cyclic quad TODF, right? That's one. Second information, what's the second one, guys? Let's work with angle F4. Angle F4 is equal to angle T2. Will that help us? Angle F4, tan chord theorem. Angle F4 is equal to angle C2. And angle C2, how can you get angle C2? Angle the center equals twice angle the circumference. Will that help me? No. I want to get here to this angle. How are you going to find angle O2? We have a cyclic quadrilateral. Will that help us? No, I've already used cyclic quadrilateral, right? If I make angle F2 equal to X, should I do that? Yeah, guys, how are we going to solve this? We got angle F4, which is I need 2 more here. If I can get angle F4 to be equal to angle F2, I think that's what I need. Angle F4 to be equal to angle O2. I need angle F4 to be equal to angle F2. Okay, let me do this now. We know F2 and F3 is, I need F2 equal to F4, right? I'm going to have multiple reasons here. So let's make angle F3 to be equal to X. F3 to be equal to X. Let angle F3 be equal to x. Actually no, let angle F4 be equal to x. Let angle F4 be equal to x. Right, so I know that's a 90, there's two 90s here, right? So that's a problem. So I know this angle is x, angle F4. Then I've got radius perpendicular to tangent, so F3 is 90 minus x. Angle F3, first we should write radius perpendicular to tangent. We should say OF is, say F, angle OFE is 90. Let's write that down. OFE is equal to 90 degrees because radius perpendicular to tangent. Now we can say angle F3 is 90 degrees minus x. Right, angle F3 is 90 minus x, but now remember F2, F3 was also 90. So if this angle is 90 minus x, then obviously angle F3 is back to x. Angle F2 is back to x because F4 is x, alright, and then remember a radius perpendicular to tangent, you got a 90 here as well, so this is 90 minus x, F3, and if this angle is 90 minus x, that's also a 90 there, so angle F2 will now become x. Right, perfect. So now you got two angles equal and then the third angle of a triangle, so angle E is now equal to angle O2. Right, and that's third angle of triangle or remaining angles, or you can say sum of angles of triangles. In other words, the remaining angles. Okay, so that's proved. This implies that triangle TFO is now similar to triangle DFE, and we got angle, angle, angle. TFO is similar to triangle DFE. Perfect. Right. Next one. Let's take the same diagram, put it down. We're almost done, guys. Almost done. Right. So next question. Right, so what do we have here? If angle B2 equals angle E, if angle B2 is equal to angle E, if angle B2 is equal to angle E, prove that. But now remember, we just proved that angle E is also equal to angle O2, right? That was the third angle of a triangle. That was the third angle of a triangle. I think angle E was also equal to angle O2. Angle E is equal to angle O2. Right, so that was the third angle of a triangle. So if they're saying angle B2 equals angle E, then it's also equal to angle O2. Okay? Prove that DB is parallel to AE. DB is parallel to AE. In order to prove parallel lines, we need corresponding angles equal. We need, why did they give us angle B2 is equal to angle E? Why B2? Okay, we know that this angle is 90. That's a right angle triangle. Okay, if this angle is 90, so then this will become 90 minus, okay, if I make these equal to x, or let's call it y, that's y, that's y, this is y. then this is 90 minus y. Will this work? That's 90 minus y. Trying to find alternate angles here, guys. Angle F4. I didn't even use a tan chord anywhere. Angle F4. See, I can see an alternate here. Maybe I can find, no. Let's work with that information that they gave us. Just 2 marks. DB is parallel to AE. If I can get angle, if I can get co-interior corresponding, I need to get this angle equal to y. Okay, so if this is y, if this entire angle is 90 minus y, alright, so this entire angle is 90 degrees, and that's y, then this will become 90 minus y. That also becomes 90 minus y. But I'm not getting corresponding. Okay, I think we need to use the radius. I think, yeah, we need to use radius, guys. Yeah, angle B2. Right, so I've got it. Yeah, so you got to think about what you have to do. Right, so remember that line is equal to that line, so that's y, then that's angle D1 is y. So let's write that down. OD equals OB, radii. Angle B2 is equal to angle D1. Angle B2 is equal to angle D1. That's because we have angles opposite equal sides, right? And then you can call it y, right? And then we got angle B2 equals angle E, and angle B2 is equal to angle E, which is equal to y. That was given, right? We made y, okay? You should actually say let angle B2 equal to y. Let angle B2 equal to y, right? So now we got y and y. This implies angle D1 equals angle E, right? We got corresponding angles equal. This implies DB is parallel to EA because we got corresponding angles equal, right? So DB is parallel to EA. Perfect. Now we have parallel lines. Now the last part is, yeah, last question, guys, come on. Prove that DO is equal to TOFE over AB. I'm sure we have to use similarity here. So let me just copy this and see what type of similarity we need to use, and then look at the diagram concurrently with this. So let's put this in the side. Right, so I've just copied that from the top, right? We need TOFE. So we got TOFE. So there we got the order, right? Right, so we can say TO over DE TO over DE equals FO over FE. Now if we cross multiply, we're going to get DE FO equals TOFE. Okay, we got TO times FE. Right, so we already got that numerator part. Now we need to look at DE and FO. We need to simplify DE and FO. We need to get rid of that. We need to look at DEFO and DOAB. Let's check. Remember the lines DEFO. Let's look at DE. DE is the small part here, right? and FO is this radius over here, right? So DOAB, we need DOAB. DO is here and we need AB there. Okay, so we can now go and replace DO with FO. So FO gets replaced with DO. We're replacing FO with DO, okay? Times DO TO times FE. Right, so because DO is equal to FO, and that's the radii. Right, so I hope you guys are understanding. Now, how is DE equal to AB? That's what we need. We need to replace the DE with AB. How is DE equal to AB? DE is equal to AB. How? Can we say that, remember that's angle A, that's Y, so we got base angles of an isosceles trapezium. Can we say something like that? Then we got DE equals AB. Unless, no, let's do this, let's use this. So remember, we just proved parallel lines, so we can use similarity. We can say DO over DE, let's add there, DO over DE is equal to DO over DE is equal to OB over AB. OB over AB equals OB over AB. OB over AB. But we know that DO is equal to BO, that's a radii, okay? DO is equal to BO, that's a radii. Yes guys, DO equals BO, that's radii. So we can say D cross multiply here, DO times AB, DO times AB equals OB times DE. Right, now because they are radii, both of them cancels out. DO and OB cancels out because they're radii, they equal, right? So now we got AB is equal to DE. Perfect. Now we got AB equals DE. We just proved that that's what we wanted. We wanted AB to be equal to DE, and now we can replace this part. Remember, we can replace the DE over here. We can replace the DE over here. Yeah, no, was this DE? DE, yeah, we need to replace this DE over here with AB. So this implies we got, let's call this equation 1, right? So from 1, DE is now AB times DO equals TO times FE. Therefore, AB is now equal to that. No, DO is now equal to that over AB. So therefore DO is TO times FE over AB. I hope you guys understood this, right? Solution. And don't forget to subscribe to my YouTube channel and share the video.